Good morning, friends. I could not record lectures for some time because of getting busy and my work. So let's start where I have left before. So let's solve some questions on recurrences. I have picked some previous year gate questions to make it interesting for you all. And let's see one simple example first. Okay. And please watch the previous lectures to get the basic knowledge, and if you don't get something you can ask the doubt in the comment box. Okay. So okay, let's start with the first one. As you all know, we represent the time complexity in terms of this function t of n, where n is the size of your input and t is the function. Okay, so let's say you are given with this recurrence relation for some algorithms time complexity. Okay, that means you are splitting your input to 4 subparts of size n over 4, and then you are finding the solution of each subpart and then you are merging for the solution. Okay, so now let's see how you can solve this recurrence relation. Okay. If you want to use the recursion tree method, okay, so let's first draw the recursion tree. So this is your original input, that is of size n, and here because you have in the equation here linear time for each level of the tree. Okay, so this is the input level, and here you are taking linear time, and you are splitting to 4 subparts n over 4, n over 4, n over 4 and n over 4. So if you consider that big of n time you are taking for processing or finding the solution of each input split, then you will take n over 4 time here, n over 4 time here, n over 4 time here, and n over 4 time here. So if you add all that, you will get n again. Okay, so again if you split this into 4 subparts, this also n 4 4 4 like this, you will get here n over 16. So here you will need n over 16 time. Okay, so if you add this whole level here, you'll get again n. So now you can see at each level of the tree you are taking n time for the processing of the input. Okay, so like this you can go up to the level where you will find n over n. Here you will get, because n over n will be 1, so time complexity this will be 1. This is the base case for any recurrence, and if it and this is given with the recurrence. Okay, so now when you will reach this level you have to stop there, because this is the base case, and till now at each level you are taking n time. Okay, so now how you will compute the whole time complexity. Now let's see what will be the number of levels here, because you are splitting the input into 4 subparts, means the branching factor of your tree is 4. Okay, and you are just going on splitting the input till you are getting n over n. So that's why the height of this tree will be log n base 4. Okay, and at each level you are taking n time. Okay, so the whole time complexity will be n, and like at each level you are taking this time. Okay, so you have how many levels? Log n base 4. Okay, so this will be the overall time complexity of this algorithm. Okay, this is how you can solve using the recursion tree method. And there is one more way you can use recursion tree and solve this recurrence. I'll tell that for reference also. So let's say you are given the recurrence relation like this. So straight away you can just factorize this one according to the relation. 4 times t, if you take n as n over 4 here, okay, so you will get n over 16. Okay, plus c times n is here, n over 4. This is your n for this sub problem. Okay, plus cn. Now let's simplify this. So this will be 4 power 2 and t of n over 16 plus, if you multiply this 4, so you will get cn here. Okay, so I can write this one as 2cn. Now let's split once more, then you can see the pattern of the solution. Okay, so if you split this sub problem again, it will be 4 times t of n over 64 plus c, and here this is your n, so 16 plus 2cn. Okay, so if you simplify this, you'll get 4 power 3 here, and this is n over 64 plus, if you multiply 4 square here, so you will get cn, and this is 2cn, so overall you will get 3cn here. So you can see here the pattern is the number what you are getting as the denominator here, this is log of that number base 4. Okay, so I can write like this, log 64 base 4. Okay, and this is t n over 64 plus, and this value also is log of 64 base 4 times cn. Okay, so if you just go on like this till you get here t of n over n, that will give you the best case, and that will be 1 here. Okay, so what you will get as the cofactor here, it will be log of n base 4, and here you will get log of n base 4 times cn. Okay, so now 4 power log n base 4 will be n, and this is 1, and here you are getting cn log n base 4. Okay, so if you watch my previous lectures, from this expression you can conclude that this time complexity will be big O of n log n base 4. Okay, this is all about the recursion tree method for this recurrence. Please watch this, and if you get some doubt, ask me in the comment box itself. Thank you.